All right, so today we're going to get into titrations. Titrations are something that we use when talking about acids and bases, and it's a way that we can determine if we have an unknown concentration of either an acid or base. We can figure out what that concentration is by reacting it with something that has a known concentration. So the way it works is you have a burette. This is usually how it works. You have a burette, which is kind of a long graduated cylinder almost, that you can control the flow of. And so you have usually the acid or base that you know the concentration of goes in here, although it doesn't matter, you could put it in either of them. And then you also have the other one, the opposite one, in here, and then you drip the acid or the base in there, and at some point you will put an indicator in here that will change color when you've reached the end point, which is hopefully also close to your equivalence point. So the end point of a titration is when the indicator changes color. So one of the most common one is phenolphthalein, and it turns pink in the presence of a base, but it's clear in the presence of an acid. So now the equivalence point is where moles of acid equal moles of base. So hopefully if you pick the right indicator, then these two should match or be really close. Okay, so we're going to drip the solution from the burette into the flask or beaker, and when this changes color, hopefully that should be when our moles of acid or moles of base. So if we know this, then we can, and we should know the volume of each of these that we put in, we should be able to get to a molarity or a concentration from that. Now, a couple things. If it's a strong acid, strong base titration, the pH at the equivalence point equals 7, because it should be neutral, because they're both strong here. If you have a strong acid and a weak base, the pH at the equivalence point will be less than 7, because the acid is stronger, so the pH will be less than 7, will be on the acidic side. And then if we have a strong base, weak acid, you probably guessed it, pH at the equivalence point will be greater than 7. Okay. We are going to today focus on a strong acid, strong base titration, and then next week we will get into these here. So this is how it might work. So let's say we have 50 milliliters of 3.0 molar NaOH is titrated with 20 milliliters of an unknown concentration, if I can spell, unknown concentration of HCl. What is the molarity of the HCl? So it should be 50 milliliters is titrated to the equivalence point. Okay, so we're assuming then that it's reached the equivalence point. So what we need to figure out, what do I know at the equivalence point? I know that moles of acid equal moles of base, right? And if I can figure out, I can figure out moles from having the milliliters and the molarity of NaOH. And then once I know the moles of NaOH, I know that that's also equal to the moles of HCl. If I know the moles of HCl and I know the volume, I can figure out the molarity. So the first step would be, I know molarity equals moles over liters, right? So I have 3.0 molarity, and I know I have 0.050 liters. I changed that, the 50 milliliters to liters, and I'm trying to find moles. So if I have molarity and volume, I multiply those to get moles. So 3 times 0.05 give me 0.15. So 0.15 moles of NaOH, which is also equal to moles of HCl. Okay, so if I know that, I'm going to take molarity equals the 0.15 moles of HCl and divide it by 0.020 liters. Again, I changed that 20 milliliters to liters, moved the decimal point over 3 times. Then I do 0.15 divided by 0.02. That would give me 7.5 molarity HCl. There's my answer. Okay, the key thing is right here, right? Is knowing once you have moles of one thing, at the equivalence point, the moles are equal. Okay, so that's the kind of problems you're going to be working on today. All right, let me know if you have any questions.